Hello, my name is Leopoldo Armesto, and in this presentation I will introduce you ESP processors. This is the outline of the presentation. First, I will introduce you about Espressif Systems is the company that have developed the ESP processors. Then I will focus on the main processors they have developed, the ESP8266 and the ESP32. I will talk about the pinout and some shields that you can use with them. And then finally, I will explain you how to set up the Arduino IDE so you can use these processors. So the Espressif company developed in 2014 the ESP8266 processor. It was basically created for or as a serial interface, and it was based on 80 commands. It became very popular for the makers community, so they could extend the Arduino Uno basically or mostly, so they could extend it and provide them with a Wi-Fi connectivity. So this is why this processor became very popular, also because of the price. It was very cheap, and this was somehow a revolution within this kind of processors. In 2015, the company released the API, so then the community started or was able to program the ESP with their own firmware. So this make that, or this as a result of this, a group of people develop a firmware which is an interpreter for in Lua, so you could program the ESP processor, and they created their own board, and this was known as the NodeMCU. Then there were a set of tools that they were developed, and particularly the ESP tool, which is a tool that allows you to program this processor with the Arduino environment, the IDE. All these tools are maintained by the community and they're published in GitHub. Then at the end of the 2015, the ESP32 processor was released, and it was developed mainly to overcome some of the limitations of the previous processor. It's much faster, it has 2 cores and more RAM memory, and also includes some GPIO encryption, and this extends somehow the possibility to be used for industrial and commercial uses. In this case, the Espressif company, developed the API, so you can program it in Arduino IDE 2. So one of the first processors that was released, it was the ESP01. It's a very tiny module, it was very cheap, and this was the module that was intended to be as a serial interface, so you can extend the Wi-Fi capabilities of the Arduino. You can provide or communicate with this board with 80 commands. There's a special set of commands that they were created for modems, and with this board you can, for instance, create a web server or remotely control a device. You can upload your own firmware, but it's a complex procedure and it requires a special programming tool, like you see here. Then the NodeMCU, as I said before, was released or developed by a group of people, and in this case they used a ESP12 processor in the first generation of this board, and then there came the second generation, which used the ESP12E version. It's an improved version. And then actually there's no officially third generation, but a company called Lolin, which is closely related with Wemos, developed a different board which is widely used nowadays. Also we have alternative to the NodeMCU, and we have, for instance, as you can see here, the Wemos D1 R2 or other different kind of varieties, using all of them the same processor, so they basically provide the same features. So here we have a comparison table between the processor that uses the NodeMCU, which is the ESP8266. It's the base for the previous one I was describing, and the processor, the ESP32, that was released, as I said before, at the end of 2015. So the ESP processor 32 has Bluetooth, which is not the case for the previous version, and also has a faster clock and more GPIO inputs, more PWM channels, more analog converters, but specifically they have more resolution, and they have more integrated hardware itself. So they have SPIs, I2C, UARTs, but also they have other features like CAN, Ethernet, touch sensors, temperature, Hall effects, and so on. So it's much more interesting to work with, obviously, with this processor. It's a slightly high, the cost is slightly higher, but it's worth it too. So this is the pinout of the NodeMCU. I show this slide because there's sometimes there's a difficulty to identify the pins corresponding to the NodeMCU and the pins for the processor itself, which is the ESP8266. So the ESP processor has a different naming for the pins. So it's the GPIO from 0, 1, 2, and so on. But the NodeMCU uses the standard or the conventional naming that was used for the Arduino, D0, D1, D2, and so on. So, and they do not correspond directly. Okay, so you have to watch out. Also, for the Wemos D1 R32, this is a processor, a board which is based on the processor ESP32, has a special pinout naming. So in the board you will see the naming like IO26, IO25, and so on. And this board particularly has the same shape as the Arduino, as you can see here. And if you can use Arduino shields on it. So means that if you're going to use these shields, then maybe it's worth it to know that there has a correspondence, these pins, with the Arduino, as you see here in the table. Also, if you're thinking about using NodeMCU, you might be interested not just using the chip itself, but maybe to use a shield, so you have an extension capabilities to connect more things and more pins in order to connect things. So specifically, you can use this board, and this board has some power pins that I show you here. So all these pins correspond to either 3.3 voltage USB or the jack input, depending which of the pins. But you have a lot of ground pins, and you have all the digital pins here, and then you have the analog pin too. So the advantage of this shield is that it allows you to have a lot of specifically ground and power pins, and a lot of digital pins, so you can connect things too. For instance, if we want to use the Wemos D1 R2, it's based on the ESP8266, and it has the shape of the Arduino too. And then we can use, for instance, this Arduino sensor shield I'm showing you here in the picture. The advantage again is that we have a lot of pins for power, for ground, and for a signal. Okay, the digital ones and the analog pin. In this case, because the processor only has one analog pin, we are only using this pin here. And if we are using the Wemos D1 R32, then again we can use the Arduino sensor shield because it's compatible with the Arduino, and again we have the power, the ground, the digital pins, and we have the analog pins. So in order to set up these processors in Arduino IDE, we need first to configure the preferences. So we have to include additional board manager URLs as it's indicated in the red box. And there you have the URLs that you have to put. Then in the tools menu, you have to access to the boards manager and select and search for ESP32 and ESP8266, and you have to install those boards, okay? And finally, once you have the boards installed, then you have to select the Wemos Lolin32 whenever you want to program the Wemos D1 R32 or the NodeMCU 1.0 if you want to program the NodeMCU. Okay, so as a summary, in this presentation I have introduced you to ESP processors. Thank you very much.